So now we are going to see the equivalent resistance in a cube by this animation video. Okay, so this is very helpful for you. So children, carefully examine all these things. I will explain you about this illustration on effective resistance, okay, of a cubical frame. We are now going to see that. See, this is a cube, okay. Imagine this is a cube, okay. So here, you know, 8 vertices are available, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices are available. You are imagine that the current I is flows on this, okay. First vertex, for example, the current I is flows through the first vertex. We are now taking the current I. So these two are equivalent resistance right now. So I1 and I1. So here this current is divided into here. The same equivalent current is passing through this. Okay, so this is I1, this is I2. Understood? Is it clear for you? So what is happening here? The current I1 is passing through this particular 1 to 2. Understood? So then 2 to 3 we can take this as current I3. Then this one is 1 to 5 is I2. These are all lies in the same plane, that diagonal plane. You are cutting this into a 2 equal half like this. Okay, understood right now? Then at the back side, you may examine here. Here it is I1, right? This is I1. What is it here? This is I3 means it will be minus I3. Okay, understood? So I1 minus I3 here. Okay? Is it clear for you or not? You are cutting this cube into two equal system or two equal cubes. For example, two equal shape now we are talking about. So this is 1, 2, 3 and 5, 6, 7 at one side. Then 1, 4, 3 and 5, 8 and 7 at another side. So these two are equivalent in appearance. And also it contains equal resistance. Okay. Then what will happen? Now this current flows in this particular fourth. Okay. Fourth vertex. Then after that we can think about this. Okay. 8th vertex, 5th vertex and 6th vertex. Okay. This one. Understood? So this one, if you take it outside, I2 is flowing into, divided into 2, right? Equal half. So equal resistance. So current I2 can be divided into 2 equal halves, I2 by 2 and I2 by 2. Understood? Is it clear for you? And then these combined. Here I1 minus I3 plus I2 by 2 from 8th vertex to 7th vertex. I hope you can be able to understand this. And then from 6th to 7th also the same I1 minus I3 plus I2 by 2. So these two are same right now. So here what will happen? These two combine together. 2I1 minus 2I3 plus I2 will be plus I2. I2 by 2 will be plus I2. Okay? Let me explain you again. So these two can be combined. This I1 minus I3 plus I2 by 2, then I1 minus I3 plus I2 by 2. These two combine and then the resultant will be 2I1 minus 2I3 plus I2 by 2 plus I2 by 2. So that will be I2, simply I2 we can say. So they have taken this frame into separate. You might have seen all these things here. So this is the voltage, right? Current into resistance. V is equal to IR. These are all the voltages across each and every segment we have taken. Okay? See here. All are equal resistance. So the final will be, if you taken everything into account, the final will be 4I1 plus 3 by 2I2 minus 5I3. Let this equation be 1. Or we are going to apply Kirchoff's voltage rule. So what is the Kirchoff's voltage rule in this circuit? So we have taken first circuit, let me repeat again. One second. Let me repeat again. I will explain you again. So just listen all of you. So this is how you are going to fix the vertex. Okay, all the vertices 1 to 8. Okay, you can number by your own. That is not a matter. Okay, you can start from here or here or here, wherever it might be. So this will be taken as 1, 2, 3, 4. Then this is 5, 6, 7, 8. Like this order we are following. Okay, in this animated video. Now this here current I is passing. Current I is passing through this circuit. Then what will happen? You just examine this plane, this diagonal plane here. Okay. So 1, 2, 3 directly the current I flows. The current I flows from 1, 2, 3 diagonally. So that let this can be equal resistances. So this current can be divided into first current I1, I1. Same equivalent resistance. Here it will be I2. Okay. So since it is dividing, right? Since this I1 is dividing, we are taking these two current as same current, that is I1, I1. Here it will be I3, I3. Here it will be I2. Okay. So if you are taking this segment out, so this is an equivalent segment. So 1, 2, 1, 3. So three resistances, we can take this is I1, this is I3. So if you take in reverse, the current I3 will be minus I3. The same current is passing through this fourth vertex also. Okay. See here. So fourth vertex. So from this to 8, 5 and 6 we are taking. So I2 is first flowing and then it divided into two equal currents. So I2 by 2, I2 by 2. Now this I2 by 2 and I1 minus I3 is moving. So it will be I1 minus I3 plus I2 by 2. From 8th vertex to 7th vertex. The same like that from 7th to 6th also. Okay. From 7th to 6th it will be like same. Here also I1, I2 by 2 plus I2 by 2. So here also I2 by 2. So I1 minus I3 plus I2 by 2. If you add these two, then that will be the 7th to 3rd vertices. So 2I1 minus 2I3 plus I2. Understood? So this is what we fixed the frames. Now we are going to segregate the equivalent. So from this they have taken the equivalent circuit. The front face, we can say this as front face. That is front face or any face 3, 7, 8. So this face 3, 7, 8. Okay, and 4. This is 4th. So 3, 7, 8, 4 face. Children, if you want to draw, you can draw it right now. So this is very easy and simple for you. So 3, 7, 8 and 4. Okay, so out of it you can calculate all these currents. So if you simplify all these currents using Kirchoff's laws, you know that in a closed circuit, sum of all the algebraic currents, based on this arrow mark you have to address the current. Okay, so what is this arrow mark? You have to address like this. See here, let me explain you. Okay, so they have taken outside. See here, this is actually in the reverse direction. Okay, so 4 to 3 it will be, not 3 to 4. So it will be minus I3 into R times. All resistors are equal, right? Equal resistance. So R times. And then what about 3 to 4 is now fixed. What is 4 to 8? 4 to 8 is proper, it is. From 4 to 8 vertex it is moving on. So I1 minus I3 into R. What about the next one? From 8th to 7th you have to multiply this current into R. That is also plus. 7 to 3 also plus. Okay. So you have to cut all these R, that is equal to, then simplify all I1, I2, I3. Do it right now. Okay, by yourself. Do it right now. And then the resultant will be coming like this. Then take an LCM. So it will be coming like the equation. So this equation we are going to apply. This is Kirchoff's. voltage law, we have applied. This equation is first equation we are taking. Next circuit will be 4, 8, 5 and 1. Okay. In this you may find, what is this? From, if you are taking 1 to 5 or 1 to 4. Okay. What is 1 to 5? It will be I2. Right. So it is going in a direct way. So I2 is positive. So I2 times R. Then 5 to 8 will be I2 by 2 times R. Then 8 to 4 will be in reverse direction, not this direction, reverse direction. So negative I1 minus I3 into R. So this is also in reverse direction. Okay, it should be counts like this. So it is in, if you are taking this way, you need to follow the algebraic sign like that. If you are taking this way, you need to follow the algebraic sign like this. You can take here also. Plus I1 R, this is plus I1 minus I3 into R, this is minus I2 by 2 into R, this one is minus I2 into R. That way also you can take, either this way or this way. Okay, you can take in a proper circuit. Okay, so this equal to 0, simplify this, then you will be getting the second equation. Exclude all R, that is equal to 0, it will be 0. All are equivalent resistance, then multiply and simplify. This will be the second equation. Okay. See here, all are in the form of I1, I2 and I3. So this is equivalent. So we have taken two equal sections, right? So you are going to equate these two and then you will find the final equation as I3 equal to I1. Okay. Wherever I3 is present, you have to substitute I3 is equal to I1. Then the Kirchoff's law we have applied for 1, 2, 6, 5, 1. Where is 1, 2, 6, 5 and 1. Okay. So if you are taking from this side, so this is I1 into R plus, what about this happens? That I3 will be 0, right? So I1 is equal to I3, if you substitute I1 is equal to I3, then this will be 0. So 0, then it will be negative. So their mark is like this. So I2 by 2, minus I2 by 2 R. So this is also negative, minus I2 R. That is equal to 0. So, and then this can be simplified. Okay. All are equal resistance. So this can be simplified. And it is equal to I1 is equal to negative 3 by 2 I2 or I2 is equal to 2 by 3 I. So you have calculated everything. Okay. Then they have taken this total. Okay. They have equated these two. Okay. So what is this? This is equivalent resistance. This is an equivalent resistance. They have taken. I will repeat again. They are going to calculate so after finishing this, okay, so they need to project, okay, from this. So this is I2, I2, I3 and everything, right? I1. So this has become 0. So the total equivalent resistance they are talking about. Okay, you are substituting I1 is equal to I3 and I1 is equal to minus I2, 2 by 3 I2. Like that, then finally you will be getting this equivalent resistance. Okay, 3 by 4 R. So like a way also you can able to find out the equivalent resistance based on this current law, current rule we can say, or current law based on Kirchoff's current law. So this animation is really helpful for you, it seems. Okay, you do work out. Okay, do revise it properly. Okay, you have to practice by drawing by your own, and then you should analyze all the circuits. You can take, I am just taking this as first, second, third, 4, 5, 6, 7, 8. You have taken any vertices, like you can tilt this cube in this way also. Okay, so all these can be done by your customized one. But the thing is, the cube should contain 8 vertices, right? That 8 vertices should be fixed in between what are the resistors? The equal resistors. Since it is equal resistors, it is easy for us to calculate the equivalent resistance. If the resistors are varying, the current also varying according to that, then that will be a tedious process. Children, you will not be given different resistors in this class 12 manner. You will be given the problem kind of thing based on this cube. You can use one thing I have explained you as a traditional method, another one based on this current law, okay, Kirchoff's law, or we can say it is voltage law also. In a closed circuit, we can use only, first you are using current law. Through the junctions you are fixing the current. Second, you are applying the loop law or voltage law. Okay, based on voltage law, you are, what is voltage law? You know, right? Algebraic sum of all the voltages or all the EMFs across that particular loop will be equal to 0. Based on that, we are fixing everything, and then the final equivalent resistance will be calculated. So just like this, I have demonstrated everything to you. If you are having any doubts or queries, do post on this. Okay. Thank you.
Bye guys.